Hello friends, welcome to this session. In these sessions, I am going to explain what is de Broglie's wave velocity and what is the wave velocity and group velocity. Friend, we know according to de Broglie's hypothesis of matter wave, any material particle when it is in motion, it has associated with a wave. Means matter has dual nature, that is wave as well as particle. The wavelength of such wave is given by lambda is equal to h upon mv, where lambda is the wavelength, it is the characteristics of the wave natures, and here mass and m into v momentum. This is associated with the material particle, means this equation 1 represent both wave as well as material particles. Okay, this is the de Broglie's matter wave or wavelength. Now let us consider capital E is the total energy of particle and nu is the frequency of the wave associated. Then according to quantum theory, E is equal to h nu. Okay, again we have expression for energy as E is equal to mc square. M is the mass and c is the velocity of light. Therefore, equating these two equation, E is equal to h nu and E is equal to mc square. The two equation we get h nu is equal to mc square and nu is equal to mc square upon h. You give the this is equation 2. Okay. Now the de Broglie's wave velocity or phase velocity Vp. Okay. You apply the usual formula, means well known formula as Vp, V is equal to nu lambda. Here suffix p, p means phase velocity. The general formula we know, V is equal to n lambda. In place of n, here I have written the nu. Nu is the frequency. Vp is equal to nu lambda. Okay. And now from equation 1 and 2, what is equation 1? That is de Broglie's wavelength, lambda is equal to h upon mv, and equation 2, nu is equal to mc square upon h. This from two equation you have to substitute. Here Vp is equal to nu lambda, therefore Vp is equal to mc square upon h. This is the nu and h upon mv is the lambda. Therefore from this mass get cancel, h get cancel, therefore c square upon v. Okay. This is the de Broglie's wave velocity, or it is also called phase velocity. Since the particle velocity v, this is the v, particle velocity cannot equal or exceed the velocity of light. Okay. De Broglie's wave or phase velocity Vp is always greater than velocity of c. Okay. This is the unexpected result, or this is the discrepancy. How can the particle velocity is greater than velocity of light? We know any particle is moving, its velocity is less than velocity of light. The highest velocity is the velocity of light. This can understood. You may first understand the first wave velocity and group velocity. What is meaning of wave velocity and group velocity? Now I will explain the wave and group velocity. Okay. The wave velocity or phase velocity of de Broglie's wave, we know Vp is equal to c square upon lambda, equation 1. According to Einstein's theory of relativity, the speed of material particle v is always less than the speed of light. Okay. The v is less than c, but from equation 1 we find that wave velocity is greater than velocity of light. Okay, which is the unexpected result. Thus it is clear that material particle cannot be equal to a single wave train. Means this discrepancy was removed by scientist Schrodinger by assuming that a material particle in motion is equivalent to a wave packet rather than a single wave. Means any particle is moving, it associate it with a group of waves, not a single wave. Okay. And now suppose the wave packets, okay, wave packet or group of waves. The wave packet contain a group of waves. Consider in simple cases, suppose two waves, you can consider the two waves, okay, having the same amplitude capital A, but slightly change in their angular velocity omega, means d omega, and propagation constant dk. These waves interfere constructively over a small region of space where the particle is located. Means this is the wave packet, okay. Here two waves are interfere constructively, okay, where the particle is located. In such a wave packet moves with its own velocity, is called as group velocity, okay. This is the wave packet and this wave packet moves with its own velocity, that is called group velocity, okay, and particle is associated with this group and particle is located inside this group only, not outside. Therefore this can understand by mathematically. The de Broglie's wave represented by, suppose two waves, I have considered here two waves. One wave y1 is equal to a cos omega t minus kx, one waves. Second wave y2 is equal to a cos omega t plus d omega t minus k plus dk. Here this omega d omega, adding here d omega, means slightly change in angular velocity. Here also dk is adding because they are slightly change in propagation constant, means greater than this, okay. The now resultant displacement y1 y2 is the displacement of one and second particle, okay. The resultant displacement y is equal to y1 plus y2. And now this is y is equal to, this is y1 plus this is y2, okay. Since we have the trigonometric equation, here two cos term, here cos a plus cos b. What is cos a plus cos b? Cos a plus cos b is equal to 2 cos a plus b divided by 2 cos a minus b divided by 2, okay. Here the 2a, this a is the amplitude, okay, this amplitude a, okay. Now a plus b divided by 2, this is the a term and this is the b term, divided by 2. Here cos a minus b, this is the a minus omega t minus kx, omega t minus kx, this is the minus, okay. B, this is the b term, b divided by 2, okay. This equation you have to practice, okay. By practicing, this is very easy. You have to substitute a plus b divided by 2 and a minus b divided 2, we get this. But we know cos minus theta is equal to cos theta. Therefore 2a cos, here 2 omega, here omega and omega is twice, okay. Here also 2k, okay. Here this is kx, kx is common, okay, 2 divided by 2, okay. You have to solve, you get these equations, okay. But here we know their change, this change d omega, change in angular velocity is very small. Therefore 2 omega plus d omega is nothing but or equal to 2 omega. Here also this change in propagation constant is very small. Therefore this is equal to 2k. Now from this you have to substitute this and we get y is equal to a cos omega t minus kx cos omega t divided by 2 t minus dk divided by 2 kx. This is the equation 4 and this equation 4 is a analytical expression for resultant wave group formed by combination of two de Broglie's wave. This is the resultant wave of, this is the equation represent the group velocity, okay, the displacement of the group of waves or displacement of the group of particles, okay. Now from equation 2, wave velocity or phase velocity Vp is equal to, what is wave velocity or phase velocity? Vp, you know Vp velocity is equal to, what is this? From this velocity distance upon time, this x upon this t, and here Suppose you have to omega t is equal to kx. Omega t is equal to kx. Now x upon t is equal to omega upon k. This is Vp is equal to omega upon k. This is the phase velocity or wave velocity. Okay. Again same thing here. You have to equate this equation is equal to suppose 0, therefore omega t divided by 2t is equal to dk upon 2 into x. This is equal, therefore x by t is equal to this divided by this is equal to omega d omega upon dk, and this is called group velocity. Group velocity Vg is equal to d omega upon dk. This is the group velocity. Friend, we know from this video we have learned the what is the de Broglie's wavelength lambda and what is the de Broglie's wave velocity. The de Broglie's wave velocity means that is the phase velocity. What is phase velocity? Okay, and phase velocity, and the particle velocity means the particle moving with group of wave velocity, particle velocity. Okay, group of waves moves, this is equal to the particle velocity. Okay, thank you very much.